Your body has a bony framework to which the muscles are attached. It contains groups of organs that perform specific functions and is controlled and coordinated by the brain, which sends instructions and receives information using electrical messages. An essential fuel that keeps this system alive is oxygen, and we get oxygen from the air we breathe. Air consists of several ingredients, but most important for us is the 21% of oxygen it contains. This oxygen is destined for the tissues of the body, and most importantly for the tissues of the brain, which can't do without oxygen for more than about 3 minutes. So let's look at how it gets there. By breathing, we take air into our lungs, which are freely suspended in the chest. The chest is a sealed cavity, and the process operates like this. When the brain tells the chest wall to lift and the muscular diaphragm to flatten, the chest space is enlarged. To fill this up, air rushes in, filling the lungs so they expand to fill the space. This process is called breathing in or inspiration. The brain then tells us to breathe out. The chest and diaphragm go back to their original positions, which of course reduces the space in the chest, pushing in the lungs and expiring the air. This happens about 16 times every minute to a healthy adult when resting, which is a point worth remembering for later in the course when we look for specific disorders of breathing. For breathing to work at all, we can see how vital it is to keep the air passages clear. They start at the mouth and nose and carry air to the throat. The large muscular tongue may be larger than you thought. It's attached to the lower jaw and, in an unconscious person, can become an obstruction, blocking the airway like this. Once past the tongue, the air goes on down the voice box or larynx. You'll notice that behind the voice box is another tube. This is your food pipe, and to prevent food going into the voice box, this little flap closes over it when we eat. Now the air goes on down the windpipe that divides into 2 branches, one for each lung. Each branch subdivides into finer branches to carry air containing oxygen deep into the lungs. The branches end in thin-walled air sacs, and the entire passageway is called the airway. Oxygen is needed throughout the body and is distributed by the circulating blood, which collects oxygen from the air in the air sacs of the lungs. You remember that 21% of that air was oxygen. The body only uses 5% of this oxygen, and the expired air still contains 16% oxygen. Oxygen is carried by the blood from the lungs to the heart, where it is pumped round the body. Every time the heart beats, pulses of this oxygenated blood surge around the body to the vital organs, particularly the brain, where oxygen is released. The oxygen passes through the thin walls of special tiny blood vessels into the tissues of the body to be used. Waste materials such as carbon dioxide gas are absorbed back into the blood and transported back to the heart to be pumped to the lungs and then breathed out. A fresh supply of oxygen is collected by the blood from the air sacs in the lungs so that the cycle can start all over again. Let's now concentrate on the heart and look briefly at how it works. It is a 4-chambered muscular pump which can be seen as having the right half, which collects the venous blood returning from the body and pumps it to the lungs, while the left half receives the oxygenated blood from the lungs and pumps it throughout the body. We'll look more closely at this later, but the pumping action is caused by the strong heart muscles that beat rhythmically 60 to 80 times a minute in a resting adult. This is the average adult pulse rate at rest, 60 to 80 beats per minute, and you will find this point useful later as well. You can feel these pulses of blood where an artery comes close to the skin's surface. Particular ones we'll be feeling are the carotid pulse at the neck and the radial pulse at the wrist. So we can see that a vital need for everyone is oxygen. A lack of oxygen is called hypoxia and can quickly lead to death. Therefore, As first aiders, we must ensure that oxygen gets to the casualty's brain as a priority above any other condition. Thus, the casualty must have an open and clear airway to let air in and out, and must be using the airway, in other words, breathing, and the oxygen from the air must be into the brain, working blood supply, circulation. Airway, breathing, circulation. It's as remember, a